Hello, this is Miss Briscoe here with today's math lesson. So the learning goal for today's math lesson is I can use a line plot to help me find an average with data given in fractions. So line plots are things that you've seen in school before, and I'm going to give you a brief overview on a line plot just to review. And fractions we've been learning for the last 3 units. So we're going to be combining the information that we know about each of those things to do a little problem solving using line plots. So let's go ahead and talk about a line plot. Now a line plot is like it's a graph, it's a data table, and it's a way that you can keep and track data. So down on the bottom you have different benchmarks or numbers or sometimes words that you can use a line plot for. And up above those, you put X's for how many of that number or of that word or of that type of thing that you have. So in this line plot, we have 1/4, 1/2, and 3/4. And then we have some X's above them. So if I were to say, okay, 1/4, I have 1, 2, 3, 4 X's. So there's 4 1/4s. There's no X's above 1/2, so there's 0 1/2s. And there's 1 X above 3/4, so there's 1 3/4. That's how you would read a line plot. So let's go ahead and work our way through this problem to see if we can go ahead and do a little problem solving using some of our fraction skills and some of our line plot skills that we've learned in previous years in math. So our problem says students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below. So these are all the different amounts of water in beakers. So by counting these up, I can know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 beakers, and they were all these different amounts of water in them. So here's the second part to my question. If the total amount of water stayed the same, what would be the average amount of water in a beaker? So this is the question that I'm trying to answer. So it's asking me that if the water was the same for all of these beakers, then, if I made the same amount of water in all the beakers, what would be the average amount of water in these beakers? So we're also going to need to know how to find the average. So average is something that you have found before. To find the average, you add up all of the numbers given and you divide by that many numbers. So for example, if I were to have the numbers 3, 5, 7, 2, 3, and 5, okay? So if I were to have these numbers here below, and I were to say, okay, I need to find the average of these numbers, what I would have to do is I would have to add them together and then divide by how many numbers I have. So to find the average of this group of numbers, I would need to add them together. So I would sit here and I would go ahead and add these numbers together. So 3 plus 5 is 8, 7 plus 2 is 9, and 4 plus 4 is 9. And I know that 9 plus 9 is 18, and then 18 plus 8 is going to be 36. So 36 is all of my numbers added together. So now I would need to take 36 and I would need to divide it by how many numbers I have. So I have 1, 2, 3, 4, 5, 6. I have 6 original numbers. Well, 36 divided by 6 is 6. So the average for this group of numbers is 6. So that's how you find the average. So what we're going to be doing is we're going to be finding the average today, but with fractions and using information from a line plot and a word problem. So let's go ahead and talk about our steps. Our first step is to count the number of each of the cups for each amount. Draw an X for the number of each times the amount is recorded to complete the line plot. So first I need to complete my line plot with the data that I was given right here. So I need to count how many 1/4s I have. So I have 1, 2, 3, 4, 5, 6, 7. So I had 7 beakers that had 1/4 cups of water in there. Now I need to count 1/2. 1, 2. I had 2 beakers that had 1/2 cups of water, and then 3/4 I had 1, 2, 3. So 3 3/4. And if I were to add 7 plus 2 is 9, 9 plus 3 is 12. And remember, I had 12 beakers, so I have all my beakers accounted for. So now what I need to do is I need to update my line graph, or my line plot, sorry. So I have 7 1/4, so there's 1, 2, 3, 4 x's above the 1/4. I need to add 3 more x's to make it 7. And then 1/2, I need to have 2 x's because there were 2 beakers with 1/2. And 3/4, I need to make sure I have a total of 3 x's for 3/4. So I've done my first step and I have updated my line graph. My second step is I need to find out the total amount of water in all of the beakers that contain 1/4 cup of water. So the reason I'm doing this is because my question wants to know what's the average amount of water in all the beakers. What would be the average amount of water? So what I need to do is I need to take each of these and I need to add up how much water what is all together. Okay, so I can't just add 1/4, 1/2, and 3/4 because I have 7 1/4 and I have 2 1/2 and 3 3/4. So I need to add up how much I have before I can add them all together. So the first step is I need to figure out I have 7 beakers that have 1/4 cup of water. So I need to figure out how many fourths do I have. So I need to multiply 7 times 1/4 because there's 7 1/4. So if I put 7 over 1, when we multiply fractions, I multiply the top, so 7 times 1 is 7, and 4 times 1 is 4. So I have 7/4, and I could turn that into a mixed number, which would be 1 3/4. So all I've done is I've added up how many fourths I have. So now I need to do the same thing for my 1/2 and my 3/4. So let's go ahead and do my 1/2 and my 3/4. So if I have 1/2, I have 2 1/2. So that means I'm going to be multiplying 2 times 1/2. So I put my 2 over 1, multiply my top numbers would be 2 times 1 is 2, and 1 times 2 is 2. Well, I know that when a fraction has the same number on the top and on the bottom, that equals 1 whole. So there is 1 whole cup in my 1/2. And the last one I need to add up is how many 3/4 do I have? So I have 3 3/4. So I'm going to take 3 and I'm going to multiply it by 3/4 to find out how much water I have all together. So put my 3 over 1 and I multiply. 3 times 3 is 9, 1 times 4 is 4. So I have 9/4, or I can turn that into a mixed number, which would be 2 and 1/4. So now what I have done is I have added up each of my different amounts. So I've done step 3 because I added up how many 1/2 I have, and I've added up how many 3/4 I've had. So what you have down here in step 5 is I need to add up all of those amounts together to find out how much water do I have total. So I need to add my fractions. Now, if you look, I already have common denominators, so I don't have to do that step. So first I need to add my whole numbers. 1 plus 1 is 2, and 2 plus 2 is 4. So I have 4 whole. Then I need to add my fractions. 3 plus 1 is 4, and then my bottom number is 4. So I have 4/4, but I know that my 4 over 4 equals 1. So this is like saying 4 wholes plus 1, which equals 5. So I have 5 cups of water total in my whole experiment. So now what I've done is I have added up all of my water. I've added up all the water right here. All this water I've added up. Now my last step is I need to divide it. I need to take all of my water and divide it by how many beakers. When I come up here, we said we had 12 beakers. So that means I need to take 5 and I need to divide it by 12. Well, we all know that a fraction means division. You just put the top number divided by the bottom number. So that means 5 divided by 12 just equals 5/12. So the average amount of water that would be in each beaker, if I were to combine them and then average it out, would be 5/12. And that is how you do a little bit of problem solving with a line plot. That's one way, and that's using averages. So let's go to another way that we can use a line plot. Now, we can always use the order of operations to help us solve these types of problems where you just combine. So what we did up top was we multiplied 1/4 times how many x's, we multiplied 1/2 times how many x's, and we multiplied 3/4 times how many x's, and then we added them together. So you could use the order of operations to help you solve that. So this is an example of what that would look like. So remember we multiplied 7 because there are 7 x's and 1/4, 2 times 1/2, and I had 3 x's for 3/4. So all they did was they used the order of operations to help them solve it. So if we were to go back, 7 times 1/4 was 7/4. And 2 times 1/2 was 1 because it was 2 halves. And 3 times 3/4 was 9/4. So they just kind of broke the steps down. And they added all this together and that equaled 5. And then you divide, it was 5/12. So they just showed you in one simple way that you could do it all as one problem. So let's look at another problem and a line plot. This is another type of problem that you would need to solve with a line plot. So Rain divides 3 2-ounce bags of rice into smaller bags. The first bag is divided into bags weighing 1/6 ounce each. The second bag is divided into bags weighing 1/3 ounce each. And the third bag is divided into bags weighing 1/2 ounce each. Find the number of 1/6, 1/3, and 1/2 ounce rice bags, then graph the results. So what they're saying is, let's underline important information. She divides 3 2-ounce bags of rice into smaller bags. The first bag, she divides it into 1/6 ounce. The second bag, she divides it into 1/3, and the third bag, she divides it into 1/2 ounce bags. So she's just taking bigger bags and dividing them into smaller bags. So the first thing that we have is we have our line plot. We need a title for our line plot because all line plots have a title. If we were to go back up here, this one says water used in cups. So we need a title for our line plot. Well, our line plot is really rice, amount of rice in bags, right? So that could be the title of our line plot. Amount of rice in bags. Pretty simple and straightforward. Amount of rice in bags. There. Now we have a title. So step 1, done. Titled our line plot. The next thing that we do is we have it labeled already for us, so that it's labeled 1/6, 1/3, and 1/2. The last step that we need to do is we need to take each of these bags and we need to divide it so we can find out how many bags each one would be divided into. So we know that they are 2-ounce bags. So we know that 2 is going to be what's going to be divided each time. So 2 is going to be divided. So for this first bag, it was divided into 1/6 ounce bags. So that means if I take 2 and I divide it into 1/6 ounce bags, I want to know how many bags am I going to get. So when we divide, remember we use KFC. So you keep your first number the same. So my 2 stays the same. I flip, the F stands for flip, so I flip my second fraction. And then the C stands for change. I change my symbol. So 2 times 6 is 12, and 12 over 1, which just equals 12. So that means that when this first bag was divided into 1/6 ounce bags, I got 12 of them. So what I would need to do is I need to put 12 X's above the 1/6. 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 bags when I divided a 2-ounce bag into 1/6 ounce bags. So let's try the second bag. Again, we're taking 2 and we're going to divide it into 1/3 ounce bags. So I need to go back to my KFC. My first one stays the same. I flip my second fraction and change the symbol. Put it over 1. So 2 times 3 is 6 over 1, which equals 6. So when I divided a 2-ounce bag into 1/3, I got 6. So that's 1, 2, 3, 4, 5, 6. And then let me do my last one. I need 2 divided by 1/2. So I keep my first one, flip my second one, and change the symbol. So 2 times 2 is 4. 1 times 1 is 1. Well, 4 over 1 equals 4. So when I divided a 2-ounce bag into 1/2 ounce bags, I got 4. And that is how you would solve the division problems and create a line plot. And that is all. And I'm going to show you one more problem. This is more of the type of problem that you're going to see when it comes time for you to do your math practice today. So let's go ahead and go through another one of these line plot problems. It says use the data to complete the line plot, then answer the question. So I have 2 directions that I need to do. It says Leilani needs to buy beads for a necklace. The beads are sold by mass. She sketches a design to determine what beads are needed and then writes down their sizes. The sizes are shown below. So these are the sizes that are shown. Okay, this is all the sizes that she needs for her necklace. So the first thing I need to do is I need to use the data to complete my line plot. So I need to look at 1/5. Okay, so let me write 1/5 up here and see how many 1/5 do I have. Any 1/5? I have 1, 2, 3. So I have 3 1/5, and that's already been done for me. If I look at my line plot, there's 3 1/5 X. So the next one is 2/5. So for 2/5, I have 1, 2, 3, 4, 5. So I have 5 2/5. So I need to add 5 X's to my line plot because there's 5 beads that are 2/5 grams. Okay, and then I have 3/5. So for 3/5, I have 1, 2, 3. So then I need to add 3 X's. Some of mine are like a plus sign, but that's okay. And the last one is 4/5. So for my 4/5, I have 1, 2. So I have 2 4/5. So if I were to add up how many beads I need altogether, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's make sure that there's 13 numbers over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. So I'm going to write a little 13 down here so I know how many I have altogether. So my first question says, what is the combined mass of the beads with a mass of 1/5? So it wants to know, what's the combined mass if I were to add up all my 1/5 beads? Well, that's easy. All I need to do is take 1/5 and multiply it by 3 because I have 3 beads that are 1/5. So if I were to multiply, it would be 3/5. Simple as that. Just multiply how many beads I have, multiply that by how much they weigh, and I can write my answer here. So 3/5. My second question is, what is the combined mass of all the beads with a mass of 2/5? So what I'm going to do is I'm going to take my 2/5 and I'm going to multiply it by how many beads that I have that are 2/5 grams. And I have 1, 2, 3, 4, 5. There were 5 beads that were 2/5. So if I multiply 5 times 2/5, 5 times 2 is 10, and 5 times 1 is 5. This can be simplified. I know that 5 can go into 10 2 times, so 10/5 equals 2. So 2 grams. And I'm going to write it grams because it's asking me how many grams. So I want to make sure that I write that in there. Okay. Then it says, what is the combined mass of all the beads on the necklace? So I need to know, what is the mass of everything? So this is where that multi-step comes in. I know the mass for the 1/5 beads, and I know the mass for the 2/5 beads. Now I need to find the mass for the 3/5 and the 4/5 and add it all together. So my 3/5, I need to multiply that by how many 3/5 that I have, which is 3. So 3/5 times 3 would equal 9/5. And I know that 9/5 added or turned into a mixed number would be 1 and 4/5. So I'm going to circle that so I can come back to that. And then I've done that, so now I need to do 4/5. There's 2 4/5. Well, I know that 4/5 plus 4/5 equals 8/5. And 8/5 would equal 1 and 3/5. So now I know the grams for each of the separate bead categories. Now I just need to add all of those together. So what I need to do, let me move this up so I have a little extra room to work, is I need to take the total amount of the 1/5 beads, which was 3/5, the total amount of the 2/5 beads, which was 2, the total amount of the 3/5 beads, which was 1 and 4/5, and the total amount of my 4/5 beads, which was 1 and 3/5. And now what I need to do is I need to add together all of these grams to find out what is the combined mass of the total necklace. So I'll add up my whole numbers. 2 plus 1 is 4. My fractions, 3 plus 4 is 7. 7 plus 3 is 10. So I have 4 and 10/5. Well, I know that 10/5 equals 2. And 4 plus 2 is 6. So the total combined mass is 6 grams. Then it says, what is the average mass of the beads on the necklace? And remember, the average is you add up all of the units and divide by how many there are. So if I add up all the amount of beads, remember it was 13. There were 13 beads, and I divide that, If I take the total mass and I divide it by how many beads there are, that will give me the average. Well, it would just be 6 divided by 13. So the average mass of a bead is 6/13. And that is problem solving with line plots, fractions, and finding the average. So you're going to have a couple practice problems that are just like this. You can pause this video, you can watch it as many times as you need. And if you need any help, please reach out to me. I'd love to meet you in Adobe Connect. Bye guys.